Welcome back to Slope as Rate of Change. In this video, we'll look at some more problems involving rate of change. So example 1. Rebecca saved her money over the past 6 weeks from her part-time job. The table below represents the amount that she has after every week. So looking at the first row in the table, I see that initially, at 0 weeks, she has $75. After 1 week, she has $125. After 2 weeks, $175, and so on. So in A, they want us to determine the rate of change. So we'll start by writing out the formula, which is y2 minus y1 over x2 minus x1. Now in order to use this formula, we need to identify some points from the table. So I'll just pick the first row. I can write that as 0, 75. And I'll pick the last row, 6, 375. You can pick any points on the table you want, you'll get the same answer. So now if I label these as x1, y1, and these as x2, y2, I can plug them into my formula. So now I get 375 minus 75 in the numerator, and 6 minus 0 in the denominator. Simplifying this, I get 300 over 6. Now I'm going to stop here for a moment and add in the units. In word problems, including the units is very important as they give meaning to what the rate of change represents. So in the numerator, I subtracted two dollar amounts. This is $300. And in the denominator, I subtracted the number of weeks. So this is weeks. So now when I divide $300 by 6 weeks, I see that this becomes $50 per week. So now this can help me answer part B. What does it represent? So this means after every week, Rebecca saved $50. So let's write this out. This represents how much money Rebecca saved each week. Now, example 2. The graph below represents Ken's trip to his cabin. So I see that on the x-axis we have the time in hours, and on the y-axis the distance traveled in kilometers. Now in A we got to determine the rate of change between points A and B. So let's write out A and B as coordinates. A is 0, 0, and B is 1, 75. So now I can use these points in my rate of change formula, which is y2 minus y1 divided by x2 minus x1. So if I label 0, 0 as x1, y1, and 175 as x2, y2, I'll plug those points in now. So in the numerator, I have 75 minus 0, and in the denominator I just get 1 minus 0. So simplifying it, I get 75 over 1. Now again, I'm going to stop here and add in the units. In the numerator, I subtracted two distances. So I'm going to see that this is the number of kilometers. And in the denominator, I subtracted 2 times, so this is 1 hour. Now 75 divided by 1 is just 75, so I can tidy this up a little bit and write it as 75 kilometers per hour. So this is essentially the speed that Ken traveled to get from point A to B. Now in B, we got to determine the rate of change between points B and C. Now this is just a horizontal line, and we know that the slope of any horizontal line is 0. So we don't even really need to use the rate of change formula. We know it's going to work out to be 0. So we can just say it is 0. Now we do need to include the units though. It's 0 kilometers over the 1 hour. So 0 kilometers per hour. So that helps us to determine what it represents. If he went 0 kilometers per hour, that essentially means that Ken was stopped, right? He didn't travel anywhere. So let's just say that this means that Ken stopped for 1 hour. Now in C, we have to determine the rate of change between this point and this point. And this point is 2,75, and up here we have 4,175. Now always write out your formula. Now this time I'm going to label this point as x1, y1, and this point as x2, y2. So now plugging that in, I get 75 minus 175, and 2 minus 4. And that is negative 100 over negative 2. So again, before I simplify this, let's add in the fact that the numerator represents the kilometers traveled and the denominator represents the time, number of hours. Now negative 100 divided by negative 2 is 50. So this works out to be 50 kilometers per hour. Now we had just calculated all the speeds in the different intervals. Between points A and B, we know that Ken traveled 75 kilometers per hour. Between B and C, he was stopped. And between points C and D, he traveled 50 kilometers per hour. So now we can answer part D. When was Ken traveling the fastest? So we know from A to B, he went 75, which is the fastest. So we can say that Ken was traveling the fastest during the first hour.